Alright guys, this is our last video with circles. So these are examples with completing the square. So don't freak out, you might be having like PTSD with completing the square from last year. It's not as hard as you're remembering it. So let's do a practice problem. So let's practice without circles, just complete the square with a normal quadratic. Practice. What happens when we have x squared plus 6x plus 2 equals 0? If I wanted to put this in a different form other than standard, one option students might suggest would be like, okay, try the diamond problem. You might remember this, where we're trying to figure out two numbers, so this is ax squared plus bx plus c, that multiply to c but add to b. So that would be like, can you think of two numbers that multiply to 2 but then they add to 6? And that's pretty tough. I don't know if I'd be able to do it in my head. So that's where completing the square comes into play. With completing the square, we're making it a perfect square trinomial without actually adjusting the equation. So step 1, I'm going to move this 2 over there. You'll also notice that I left a big space right here. What I'm going to put there is half of this value squared. So this is going to be plus 6 over 2 squared. Now, my equation is super balanced. I'm not just allowed to add whatever I want whenever I want it. If I did it on this side, I'm going to have to do it over here as well. So I'm going to add 6 over 2 squared on both sides. So we just simplify it down. We've got now x squared plus 6x plus 6 over 2 is 3, 3 squared is 9. Same thing over here. So this is now what we call a perfect square trinomial. Why do we call it a perfect square trinomial? Well, let's do that diamond problem. Can you think of two numbers that multiply to 9 and add to positive 6? I feel like it's on Dora the Explorer. Right, it's 3 and 3. So you could write this as x plus 3 times x plus 3, but that is a much longer way to write something that can be simply written as x plus 3 squared is equal to negative 2 plus 9 is 7. Okay, so in that process we have completed the square with a quadratic. So how does this apply to our circles? So this is the 7th type of problem. So let's do 7a. X squared plus y squared plus 6x equals negative 5. So this does not look like what we're used to. First step, I'm going to get all the x's together. So I'm basically going to move this 6 over here. So now we've got x squared plus 6x. I'm going to leave some space because I'm going to have to complete the square there. Plus y squared equals negative 5. Just like in the above problem, I'm going to take that middle value right here. I'm going to cut it in half. And then I'm going to square it. Since I did it on this side of the equal sign, I'm going to have to do it over here as well. make my equation balance. Now, we know how this one turns out. This becomes x squared plus 6x plus 9. I'm going to drop down everything else. Plus y squared equals negative 5 plus 9. Now, this becomes x plus 3 squared plus y squared equals 4. We're now in standard form of a circle. So if I wanted to identify the center and the radius, you just use what we know about the equation. So the center is at negative 3, 0, and the radius is the square root of that value, so 2. Let's graph it. So we've got a center at negative 3, 0, and it's going to go all directions 2 units. I'm done. So sometimes if it doesn't look like the standard form, we're going to have to force it to look like it. So let's do another example together with completing the square, and then you can try one on your own. So here comes 7b. We've got x squared plus y squared plus 2y equals 6y plus 32. We're going to have to do some rearranging to get everything nearby itself. So I'm going to move this 6y over. We've got x squared plus y squared minus 4y. We'll leave some space equals 32. So I'm going to take this value, this negative 4, cut it in half and square it. So we've got plus negative 4 over 2 squared. My equation's in balance, so I'll put it over here too. And I'll start solving down. So I'm going to leave this x squared alone. Negative 4 over 2 is negative 2. Square it becomes positive 4. The x squared is just chilling. He's not really doing a whole much. So I have to think of two numbers that multiply to positive 4 but add to negative 4. So that would be negative 2 and negative 2. I'm not going to write x minus 2 times x minus 2. Instead, I'm just going to write, sorry, not x, but y minus 2 squared equals 36. We're now in standard form, so we can write the center is 0, 2. It's like x plus 0. And our radius is the square root of that number, 6. So let's graph it. Center at 0, 2. And it's got a radius of 6 in all directions. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, it's a big circle. Okay. So, there is our circle for 7b. Completing the square, not too bad. You can do it. I believe in you. 7c. This one's the one for you. I'm going to write it down here because it's a little bit long. X squared plus y squared plus 14x equals 2y minus 41. Okay, so this one's going to need you to rearrange some stuff. I would probably move that 14x with the x. I would move that 2y with the y. You're going to have to complete the square 2 times. For 7a, we only did it once because we only needed to do it for the x. For 7b, we only did it once because we only needed to do it for the y. This time, you're going to have to do it for the x and the y. Okay? Try your best. That's the end of the videos. Our homework for these notes is going to be pages 1 and 2. So, just like the trig packet, there'll be a big conics homework chapter. Homework packet. So this one's just pages 1 and 2 for those. And if you have questions, all you gotta do is message me on Edmodo. Tell me, like, okay, for question 7b, I don't understand this step, and I can help you out that way. Yay, online learning. It's going to be good. So, this was just circles. We're going to do a little bit more. What else do we have to do in this chapter? For this week, we are going to be doing circles, ellipses, and hyperbolas. We're going to do parabolas next week. Okie dokie. That's it. Alright, bye y'all.